Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve the next questions from time chapter Keith Williams. In the previous lecture, I solved first 10 questions. In this video lecture, I will solve the next 10 questions. So, question number 11. At what times of the year does the length of daylight change most rapidly? Okay, the length of hours of daylight change most rapidly. Equinox, autumn equinox, winter solstice, spring equinox, autumn equinox, summer solstice and wind solstice, spring equinox and summer solstice. So the correct option is at the length of the hours. So the correct option is option Bravo. Spring equinox and autumn equinox. Now these two are the seasons when the sun when the sun is directly over the equator. Directly over the equator. So both hemispheres receive equal amount sunlight. Therefore, the duration of day and night are equal. Okay. So during spring equinox, after that, so when the sun moves from or moves northward or southward from the equator, the changes in the length of daylight will change most rapidly. During that phase, during the movement of the sun from the equator northwards, equator southwards is most rapid. So that is the answer. Next, civil twilight occurs between what? So civil twilight will happen when the sunrise and sunset and when the sun is 6 degree below the horizon, when the sun is between 6 and 12 below the horizon, 12 and 18 below the horizon. So civil twilight happens when center of the sun is between 0 degree to 6 degree below the horizon. 6 degree and 12 degree is your nautical twilight. 12 degree and 18 degree is your astronomical twilight. So you will find these three definitions in Time 3 chapter of Oxford. Remember these three definitions and the values. Next, what is the highest latitude on the earth at which the sun can be vertically overhead? Okay, so let's say this is your earth. Okay, there is equator, 0 degree equator. We have Tropic of Cancer. We have Tropic of Capricorn. So the sun moves between these two latitudes, 23.5 south and 23.5 north. Okay, so the movement of the sun is limited between these two latitudes. Okay, so the sun will be overhead a particular latitude, any latitude between these two latitudes. Okay, so the highest latitude will be either 23.5 south or 23.5 north. 23.5 north and 23.5 south. Okay, so all the places between these two latitudes will have sun directly overhead. Beyond these two latitudes, the sun will not be directly overhead. Okay, it won't be directly overhead at 90-degree angle. It will be any angle less than 90 degree, depending how far away you are from this Tropic of Cancer or Tropic of Capricorn. Next, question 14. The UTC of the end of evening civil twilight at this position on 15th of August is what? So we will have to use air almanac table to find out the end of evening civil twilight. Now in the air almanac table are in terms of LMT, local mean time. Okay, so So from chapter number 3, from chapter number 3, take the air almanac table for the month of August. So the date is 15th August. Yeah. So this table on page number 445, evening civil twilight, August, 15th of August, the last column. And the latitude is 51 degree north, 51 degree north, right? So 51 degree north is, we don't have 51 degree north, we have 50 degree north latitude and 52 degree north latitude. So just check those two values. So at 50 degree north latitude evening, so at 50 degree north latitude the time is 19:55, and at 52 degree north latitude the time is 20:03. So we will select for 51 degree north latitude, we will take time which is between 1955 and 2003. So let's take 1959. Okay, so LMT time of evening civil twilight is is 1959, 1959. So this is LMT. Now let's convert this into UTC. Now there are two longitudes given to us, 8 degree west, and then UTC longitude is 0 degree prime meridian, right? So now 8 degree west longitude is to the east, of 0 degree prime meridian, 0 degree prime meridian. Okay, so any longitude which is to the, correction, 8 degree west is to the west of 0 degree prime meridian. Okay, to the west of it. Western longitudes are behind in time compared to their eastern longitudes, right? So the LMT time 8 degree west is 1959. Now we want to convert this into UTC time. So what formula will you use? UTC time will be more than LMT time because UTC longitude is to the east of 8 degree west longitude. So the time at UTC meridian will be more than the time at 8 degree west meridian. So LMT plus the difference between longitudes between them divide by 15. What is LMT time? 1959 plus D long. 8 degree west 0 degree is 8 degree, divide by 15 degree. So 1959 plus 8 divided by 15 is equal to 32 minutes. Is equal to 32 minutes. That is 20 hours 31 minutes. So UTC time is 20 hours 31 minutes. Okay. Next, what is the standard time in Hawaii where it is 6 o'clock standard time on 16th of July in Australia? So we will use Air Almanac table again. So standard time in Australia is 0600. The date is 16th July. 16th July. Okay. Now we will convert the standard time in Australia into corresponding UTC time. Okay, it's a two-step process into UTC time. So from chapter 2, use the Air Almanac table from chapter 2. Now Australia is to the east of prime meridian. Okay, east of prime meridian. So you will use the table number 1, which contains places, or which consists which has a list of places which are to the east of prime meridian, and therefore will be ahead in time of compared to UTC time. So over here, Australia, you will see Australia is here, and the place is Queensland in Australia. That is 10 hours. So it is 10 hours ahead of UTC time, right? So standard time in Australia is equal to 10 hours ahead of UTC. Now what is standard time in Australia? 0600, 10 hours plus UTC. So UTC will be 0600 minus 10 hours. So 6 hours minus 10 hours is minus 4 hours. Add 24 to this, so plus 24 will give you 20 hours. So UTC time is 20 hours previous day. Now since there is minus sign here, this means that we have gone back to a previous day, which is 15th of July. Now using this UTC time, we will find standard time in Hawaii. What is the UTC time? 2000, and the date is 15th of July. Hawaii. Hawaii is a place which is to the south of US, and US we all know is to the west of UTC. So we will use table number 3, which has a list of places which are to the west of prime meridian and therefore slow on UTC, meaning running behind in time compared to UTC time. So Hawaii is a place over here. So Hawaii is a place which is 10 hours behind UTC time. 10 hours behind UTC time. So standard time in Hawaii will be equal to UTC time minus 10 hours. So 20 hours minus 10 hours is equal to 10 hours. Okay. And the day will be the same, that is 15th of July. So correct answer will be option number alpha. 10 hours on 15th July. Question number 16. If it is if it is 7 hours, it is not 9,000. If it is 7 hours, morning 7 in Kuwait, what is the standard time in Algeria? Again, this is a two-step process in which we will find UTC time in step 1. So standard time in Kuwait is equal to 0700. So UTC time, corresponding UTC time will be how much? Now Kuwait is a place in the Middle East, and all Middle East countries are to the east of UTC meridian, prime meridian, right? So we will make use of table number 1 because it has a list of places which are to the east of prime meridian and hence ahead in time compared to UTC time. So Kuwait. Okay, over here. So Kuwait is 3 hours ahead of UTC. So standard time in Kuwait is 3 hours ahead of UTC time. So 0700 is 0300 plus UTC. Therefore, UTC time will be 0700 minus 0300, that is 0400, and the day will be the same, whatever day. So same day, I am writing here same day. Now step number 2, convert this UTC time to corresponding standard time in Algeria. Now Algeria is a place which is also to the east of prime meridian. Okay, Algeria is 1 hour ahead of UTC time. Okay, Algeria, standard time in Algeria equal to UTC time plus 1 hour. So 4 hours plus 0100, that is 0500. So standard time in Algeria is 0500, same day, same day. So correct option is option Bravo. The next question number 17. At 12 o'clock standard time in Australia, what is the standard time in Hawaii? Okay. So again a two-step process. Step 1, convert standard time in Australia corresponding UTC time. So 12 o'clock, the date is 10th July. UTC time will be how much? Now Australia is a place which is to the east of prime meridian, and therefore the time in Australia will be ahead in time compared to UTC time. So Queensland, Australia is 10 hours ahead of UTC. So standard time in Australia is equal to 10 hours plus UTC time. So 12 o'clock is equal to 10 hours plus UTC. So UTC will be equal to 12 hours minus 10 hours. So UTC time will be equal to 2 hours. Okay, will be equal to 2 hours. And the date will be the same, 10th of July. 10th of July. Step 2, convert this UTC time, which is 2 hours, 10th July, into standard time in Hawaii. Now Hawaii is a place which is to the west of prime meridian, and therefore the standard time in Hawaii will be later than UTC time. So go to table number 3 and you will find that Hawaii is a place which is 10 hours behind UTC. 10 hours behind UTC. So standard time in Hawaii is equal to UTC minus 10 So 0 standard time in Hawaii will be 0200 minus 100. So 2 hours minus 10 is minus 8 hours. That means we have gone back to the previous day. Add 24, you will get 16 hours. Which is 9th of July. Previous day 9th of July. Okay. So 16 hours 9th of July. Option A. What is the time of sunrise in Vancouver, British Columbia, Canada on 6th of Jan in terms of UTC? Now you will use Air Almanac table. Get your answer in LMT. Convert that into UTC. So remember 49th north is the latitude and January is the month. So go to so sunrise 6th Jan. This table. For the month of January, we don't have 6th Jan, we have 5th of Jan. So we will use that number for 45 north. So this is 45 north. So at 45° north latitude, sunrise time on 5th of Jan is 0738. 0738. Okay. So let's write it here. LMT time is 0738. The two longitudes given to us are, one is for prime meridian 0° and this is 123°, 23 minutes west longitude, and the second one is 0° prime meridian. Now D long is equal to 123°, 23 minutes, right? Next, western longitudes 123°, 23 minutes west longitude to the west of prime meridian. Is to the west of prime meridian. Therefore, LMT time at 123°, 23 minutes west longitude will be behind UTC time. So the formula I'm using is UTC time equals to LMT time plus D long divided by 15. LMT time is 0738. D long is 123°, 23 minutes divided by 15. So 0738 plus 123°, 23 minutes divided by 15 degree, 8 hours 13 minutes. So 8 hours 13 minutes plus 7 hours 38 minutes is 15 hours 51 minutes. Okay, so the correct answer is 15 hours 51 minutes, or approximately closest option is option Charlie, 16 hours 8 minutes. Next, question number 19. Angle between the plane of ecliptic plane of the Earth orbit and plane of equator is 23.5 degree. Okay, so if this, let's say this is the elliptical orbit of the Earth around the Sun. This is the Earth Here is the equator. Okay, so the angle between them, orbit and this orbit, and this equatorial latitude is equal to 23.5 degree, and that's why we have 23.5 degree north Cancer, 23.5 degree south Capricorn. Next, last, the duration of civil twilight is between sunset and when the center of the sun is 6 degree below true horizon, sunset and when the center of the sun is 6 degree below visual horizon, between sunset and when the center of the sun is 6 degree below visual, and when the sunset and between sunset and sunrise. So the correct option is when the sunset of the sun is 6 degree below the visual horizon. Option C. With this, we will stop here. I will do the next 10 questions in my next video lecture. So do watch that lecture. Hit the like button if you have liked this video lecture, and do share this video with your friends. All the best.